Hi everyone, and welcome to our lecture on repetition. So just like conditional branching, repetition gives a lot of power to our programs. Conditional branching gives us the ability to program decision points in our code. Repetition gives us the ability to repeat some set of actions a number of times without having to know exactly how many number of times in certain situations, and B, copy and paste that a million times in our program. It's a way to keep our code nice and clean and add some flexibility. So say we're getting some sort of value from a user, or we're evaluating some condition and we want to continue to repeat something until a condition is met. Repetition is what's going to allow us to do that. There are different kinds of loops that we can use for repetition in programming. There are things called counted loops, where we're going to be repeating something a number of times. These usually are going to require a variable that will keep track of how many times something has been done. And we often, actually always, call that in computer science a counter variable. Usually we'll use like one letter for that variable just to keep it really simple. It's often I is what the counter variable is, but it's great for things like in the real world, if we were thinking about wash exactly 35 dishes. I don't know when that would ever be the case, but you never know. Or run exactly 4 laps. That seems a little bit more realistic to me. There are also loops that are called conditional loops. So they're going to repeat while some condition is true, and they'll stop once that condition is false. So real world examples of this, while still alive, breathe. A better one about dishes is while there are more dirty dishes, wash one. That will continue until there are no dirty dishes, and that condition would be false. Sometimes our conditional loops will also check a counter variable. So for instance, we could rewrite that run 4 laps as, well, the number of completed laps is less than 4, run another lap. So we can do different things like that. Conditional loops will be able to do everything that counter loops can do just by using that condition in there. But they can also do more. So they are able to evaluate relational expressions and logical expressions and all of those other kinds of expressions that we dealt with in the previous chapter. So just to go through some examples here, we want to think about, are these likely counted loops or conditional loops? And some of them, depending on the way we actually phrase them, could be a little bit of both, but I'm going to give you one definitive answer for each. So for this one, first one here, we have run around the track 4 times. Since we know we need to do something a distinct number of times, that's going to be a counted loop. Similarly, make 2 dozen pancakes. We know how many we need to make, counted loop. Wash all the dishes. We don't know how many dishes there are, so that would be a conditional loop. Add up the cost of all the groceries. Again, we don't know how many groceries there are, so it will be a conditional loop. Read every word in a book. Don't know how many words there are. Conditional loop. Send the text message to all of my friends. Don't know how many friends there are. That's a conditional loop. And then do 5 sets of 12 reps. We know exactly how many we need to do, so that would be a counted loop. We have one example here of a loop that has a counter variable I, and then we're using that while keyword to evaluate some sort of condition. In this case, we're doing something while I is less than 10. So while I is less than 10, we are going to print I and then increase that counter variable by 1. So what will happen here is for the very first iteration, we're going to say I is equal to 0. Is 0 less than 10? Yes, it is. So we will print out 0 and then increase it by 1. And then it will go back to the top of that loop and say, okay, is 1 less than 10? Yes, it is. So we're going to print out 1. And then we're going to increase I to the value of 2, and so on, and so on, and so on, and so on, until it gets to 9. So when I is equal to 9, we'll say, is I less than 10? Yes, it is, so we'll print 9. Then we'll increase this to 10, and we'll check this condition and say, is 10 less than 10? No, it isn't, so we skip to the bottom of the while loop. In this case, there's nothing else to do, so the program would just end. So what this would actually end up doing is print the values 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 to console, all on their own distinct line. And you can type this out in PyCharm and see that for yourselves. Highly recommend doing that. What we're going to do now is a slightly different example than what we saw, but it's kind of related. We're going to write a program that reads an integer from the user that has to be positive. So we're going to put that reading in from the user inside of a loop. And the condition for the loop will be, while this number that we've read in is not positive, ask for a new number. So, oops, let me show you how to go about doing that. My mouse is very tired, apparently. It's kind of lagging for some reason, and I'm getting very frustrated by that. All right. Now, why can't I see PyCharm in my examples? 2 seconds. Exit it, and then I will reopen it and see if that solves my problem. Otherwise, I'm just going to write it on the screen if that doesn't work. Come on, computer. There we go. That's loaded up. Oh, it really doesn't want to accept this as a thing. Well then, fine then. We're just going to write it outside of PyCharm because for some reason... What background tasks are running? Oh my goodness, my poor computer is absolutely just having a time of it. We'll just write it on this screen. You can write it in PyCharm itself so that you can actually run it and test it. So the very first thing we're going to want to do is actually read in a number to start with from the user. So we're going to store that in a variable called number. And we're going to use that input command to ask the user to enter a positive integer. And remember, the computer will read whatever the user enters as a string. So we actually want to tell the computer that we're smarter than it. I always say that whenever I use this command. Stupid computer, I am smarter than you, and I actually want this to be an integer. So I had shown in the previous lecture how you could do that in 2 separate lines, but you can also do that within a single line by just wrapping that input call inside of an integer call function. And either or will work, so whatever one you prefer you can do. Then we want a loop. So in this case, because this is going to be a condition, we want to continue to do something while we're in a certain state, i.e. the user has entered a negative number. So we will add in a while loop that checks to see if number is less than 0. Then we will tab over and we'll ask for a new number. And we can read it into that exact same variable because that's what's going to be checked in our condition above. And again, we want it to be an integer, so I'm just wrapping it in that integer call, making sure I have all of my brackets so that the computer doesn't yell at me. And I'll say, I need a positive number. Try again. And so that will continue to happen over and over and over again until the user enters a positive number. We could have another print statement at the bottom that says, finally, when they enter a positive number. So what I would recommend you do is type that out into PyCharm yourself, try some different values, try those negative values, see, yes, this gets asked for again when I enter one of those negative values, etc., etc. So for loops are the other type of loop that we can use within Python. They're often used for counting loops or when we know we need to do things a certain number of times because it will manage that counter variable for us on its own, which is amazing. I love it so much because when I first started programming, I was learning C++, and when I was learning while loops, the number of bugs I had because I didn't increase a counter variable, etc. in a while loop. It was wild. It was very frustrating. So this example, we have a variable up here called course number. It's a string that is just the name of this course that you're in right now. And then we have this for loop. So the keyword here is for. Then we have this variable, which is used within the for loop for each iteration. We have this keyword in, and then we have that variable that we used up here. So with for loops, you could either have that be a string. You could also have that be a call to range, if you remember from the textbook. And then in this case, it's just printing C. So when we pass in a string to a for loop, it just takes one character at a time from that string. So this is just going to print each of the different letters, including the space and digits of that string we passed in on a single line by itself. Again, feel free to practice your programming skills, type that in to PyCharm, and see exactly that is indeed what's happening when you see the output onto the console. Next, we are going to want to write a program that will print out an integer number of plus signs. So in this case here, I really want my PyCharm to work. I don't know why it's not being recognized by my computer. Oh well, such is life, I suppose. So in this case here, we don't know the integer number of plus signs. Let's just ask for it from the user. We can because I make the rules in this class. I don't know. In an assignment, we would give you more details, like put it into a variable and just give it a value or read it in from the user, etc., etc. But for the sake of this example, let's just read it in from the user. We've done that before, so we know how to do that. So again, I'm going to make a variable. I'll call it number because that's going to tell us how many integers we're going to be printing out. We're going to use that input variable to ask the user to enter a positive number. We will assume that the user has best intent and will only be entering positive numbers here. So we don't need that while loop that just keeps asking them for a positive number every time they enter a negative one. But we do need that int command that tells the computer we are smarter than it and we know the user will be entering a integer. And then all we need to do to print out a whole bunch of plus signs, we could either use a while loop, but I'm going to show you the example with a for loop. So we could do for I. This letter, again, could be whatever you want it to be. It's the name of the variable that we're going to use within the loop. Or if you want to think of it another way, when we don't use it within the loop, it's just our counter variable. So it's just the counter variable that's getting managed in the background by Python, which is 10 out of 10. So I in, and then we're going to use that range function that we talked about in the textbook. And in this case, we'll just use the range of the number that was entered by the user. Once we have that, we're just going to print the plus. And we have to put that in a string, otherwise the computer freaks out at us. And so that will just print out an integer number of plus signs on every single line, or each on their individual lines. If we wanted them all printed on the same line, we can add in a second option to that print command where we specify what the end would be. So right now the end is like an enter key, so it's going on a new line. We can just put that to be an empty string if we want that to be a whole bunch of pluses in a row. So again, type those options out into your computer, into your PyCharm, run them, one without this extra addition that we have in our print sign or print command, and then one with, and see that output, that difference that we get with those two things. So just to review that range function a little bit more, what it is a function and it's going to return a sequence of numbers for us. So because it's returning this sequence of numbers, we're often going to use them within for loops. So from the following function calls, what you can do if you have Python or your PyCharm and it's working and all of these wonderful things, you can just wrap those in a print statement to see the exact output that they're going to get. But I will also walk you through the exact output you'll get as well. So remember, when you pass in just a singular number, it's going to start at 0 and it's going to go to 1 minus the number that you passed in. Whoops. Where's all my things? Here we go. So in this case, we're going to get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 is not included because computer scientists start counting at 0. We say we want 10 items in this range, so that's going to be 0 to 9. Yeah, we do silly things. When we are passing in two numbers, we're passing in the start and the end of that range that we want. But again, remember, it's 1 minus that range. So in this case here, we will get 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And we won't get 15 because we don't include that final number. It's like a less than, not a less than equal to. It's kind of how my brain typically thinks about it. Now when we have 3, we have our start, we have our stop, and then we have our step size. So by default, the step size is 1, but we can change this to be whatever we want. It could be increasing, it can be decreasing, it could be 2, it could be 5, it could be 17, whatever we want. So in this case here, it would start with 5, and then it goes up by 2. So it would be 7, 9, 11, 13, and then again, 15 is not included, so it would end at 13. Because if we added 2 to 13, it would be equal to or greater than that end step that we specified. And then the final one here is a bit of a trickster. It's actually invalid because it starts at 10 and it wants to go to 5, but we specified 2. And there's no way to go from 10 to 5 by adding 2 to it. If we specified it as -2, it would work. But if you put that into your pie chart right now, it's going to yell at you. And we expect it to because the computer is not smart enough to fix our mistakes for us. These ones that we have here, we want to write the calls to range that would actually get us these values. So in this case, remember, and here's one thing I'll put over here. Range, we often have our start, our stop, and our step. If we have something simple, we can just include the start. If we have something a bit more complicated, we have the start and the stop. And if we have something much more complicated, we would have all 3. So for these examples down here, this first one is pretty complicated. It's starting at 10, it's going to 1. We're going to have to tell the computer how to do this because it's not going to be able to figure it out itself. So in this case, we have a range. It starts at 10. And we're going to want it to end at not 1, but 0. So 1 past where we want it to end, and it should go down by -1 each time. So you'll see it's going from 10 to 9 to 8 to 7. That's down by 1 each time, and that should work just perfectly. Our next one that we have here, we have, again, a pretty complicated one. That step size is doing something much more complicated than just a 1. So we would want a range call. We would start at 8. We're going to go till 1 past where we actually want. So in this case, it would be 27. And this is going up by how many each time? 6 each time. So 6. And that's how we would get that range. And if you don't believe me, put that into PyCharm, wrap it in a print statement, and see what gets put out to console. All right, for exercise 6, we have this example here of what's getting printed out to console. So we have this range. So remember, if we go back to the previous slide, that this value or these values here are what would actually be generated by that range call. So it would start at 0 and it would go to 9 and go up by 1 every iteration or every repeat of that loop. Oftentimes, computer scientists use the word iteration. It just means the next time that loop is executed, the next time we're repeating something. So you'll hear me use that word a lot. And so when we first start this off, I is going to be equal to 0. Inside of that loop, it's just printing I, and then it's printing, instead of a new line, it's just a single space there. So what this will end up doing is print out that sequence that we got from range. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, just with spaces in between them. Okay, and so this is a take-home example. So what you're going to do is try doing this on your own. This is kind of a more tricky exercise, so make sure you give yourself some time to actually do this. You're going to write a program that reverses the digits in a non-negative integer. So there's some examples there. For a non-negative integer, if we divide it, integer division, by 10, we're going to get the rightmost digit removed. So we can use that to our advantage within that loop to just get one of those values. And then if we use the modular function, we're going to get the rightmost digit of n. So there's a way that we can get that value, maybe store it in a new string, maybe, that we're going to be adding to. And then we can also remove it for the next iteration of that loop by using that integer division. There is a solution posted for this in the exercise solutions, but do try this on your own first. It might take some time. Give yourself some time. Ask some questions in lab. Come to help hours. We're here to help you out with that. The final thing that we're going to talk about in this section is infinite loops. Infinite loops are my nemesis. I will never forget. I think it was my first day teaching, first time teaching comp sci for sure. I was teaching loops, so it wasn't the first day. It would have been like halfway through the semester, give or take sometime. And I was confidently typing out my loop exercises, and it took me a solid 10 minutes to figure out why my loop was running forever. I couldn't figure it out. I just had a beautiful infinite loop for all of my class to see. And none of them corrected me on it either, so... But infinite loops happen when we don't update that counter variable, and then the loop just keeps on getting executed because that condition doesn't change. So we see them a lot more when we're using while loops than when we're using for loops, because for loops are going through that specified sequence. They're doing something X number of times, whereas while loops, if we scroll all the way back here, we have this condition, and if we didn't add this I variable, whoop, oh, my leggy mouse. Come on, I want to click my drawing thing. There we go. Yes. So if we didn't include this line, it would just continue to print out 0 all through our screen until our computer ran out of juice. So oftentimes when you see that behavior happening, it's because you forgot to add that update within your while loop that's updating that counter variable. Happens to the best of us. Sometimes happens in front of lots and lots of people. It's okay. Oftentimes we get the question of how do we choose between a while loop and a for loop. So oftentimes you will only use a for loop, and the only time that you're going to use a while loop is when you want to do something with a condition. So for loops, we can use them for doing things X number of times, looping through strings, which we often do when we have sequence information. But if we wanted to do something until a condition is met, we would have to use a while loop, because a for loop just wouldn't work for that. So that's when you would use a while loop. If you have questions about that when you're doing your assignments, etc., just reach out. We're here to help. Happy coding.